So here we are having benzene. Now benzene is, wait a minute. Okay, we were talking about the substrate, reactant. Now benzene is known as substrate. Benzene is known as substrate because the reaction will take place on benzene, and then after the presence of benzene we can observe in another form in the product. That's why it is known as substrate. Means again, the chemical on which the reaction will take place is known as substrate. Now reactant, the chemical by which the reaction will take place. Here we are having nitric acid, HNO3. From nitric acid, by reaction with sulfuric acid, we will get NO2 plus. Now this NO2 plus will react or attack on benzene, and as a result we will get nitro group over here. So that's why we can call this is a nitrobenzene and reaction is nitration. Instead of this HNO3, if we take Cl2 and other catalysts like FeCl3, then instead of NO2, we will get Cl, that is called chlorobenzene. That's why it is known as chlorination. So we can say that reactant can decide the name reaction or type of the reaction. Now third point, that is role of sulfuric acid. Here in the product, you can see there is absence of sulfuric acid, even though in the reaction it is involved, and that's why it is known as catalyst. How it acts as a catalyst? From HNO3, H2SO4 react with HNO3 react with sulfuric acid and we will get NO2 plus, and then after that NO2 plus will react with benzene. After completion of the reaction, again H2SO4 will be available in its original form. That's why it is known as a catalyst for the reaction. So here we have discussed about three terms: substrate, this one first, this one is known as substrate, this one is known as reactant, and this one is known as catalyst. So I think it is clear to all. Now, types of reaction. How many types of reactions are there? There are different types of reaction. Here I have taken example of several reactions only. First is combination or synthesis reaction. Combination means here you can see A and B molecules or A and B atoms. These molecules are react with each other and we will get the product, that is called AB. This is called combination or synthesis reaction. Sometimes if we are having some molecules, that is called AB molecule is there, from AB molecule dissociation will take place and we will get A and B separate. Okay, this type of reaction or reactions are known as a decomposition reaction. Here I can give the example. Suppose if I am having water H2O, by electrolysis method, mean by passing electric current, we can convert it into H2 plus 1/2 O2. So this is called decomposition. Here in combination, suppose I am having hydrogen, that is H2, I am having oxygen. Now hydrogen and oxygen react with each other and we will get water. So this is known as combination or synthesis reaction. Then after, another is known as single replacement reaction. Single replacement reaction means what? If you are having component A or compound A react with BC, another compound, from this replacement of B by A, and we will get the product AC, that is known as single replacement reaction. Then double replacement reaction. In this compound we are having AB compound react with CD. Now replacement of B by D, replacement of B by D, and replacement of C by uh, sorry, replacement of B by D. So what we will get? AD, and then after we will get B and C product, or C or B product. So this is known as double replacement reaction. Sometimes combustion reaction is also take place. Combustion reaction means if you are having hydrocarbon C6H6, let's say benzene react with oxygen. Normally in a lab we perform this type of experiment. So that is called combustion reaction. Due to the combustion reaction, what we will get? We will get carbon dioxide, water and flame. This you have observed in the lab. Suppose if you are having any organic compound, when organic compound you put in the flame, immediately the fire will take place. That is called combustion reaction take place, and we will get the energy, heat. Combustion reaction is also take place in our vehicles. When we are using petrol, diesel, at that time the combustion reaction will take place with oxygen, and we will get carbon dioxide, water and heat plus pressure, and due to that our engine or our vehicle can move further. So these are the types of reactions. Already I have given example. So combustion reaction, then decomposition. As I said, if you are having AB and then from AB we will get A and B separate, that is called decomposition reaction. Suppose if you are having NaCl solid, when we add NaCl in a water, okay, NaCl, here you can say NaCl solid if you are having, when we add this NaCl into water, immediately what we will get? Cl minus Na plus. So dissociation, decomposition of molecule will take place. Combustion reaction, already I have given example of hydrocarbon plus water, we will get oxygen, we will get carbon dioxide plus water and heat, energy and pressure also. Then neutralization reaction, when you are performing some reactions in the lab, at that time we are having HCl and NaOH, suppose. So this is example of double replacement. In the double replacement, what we have discussed, AB and CD, what we will get? AC and BD, or AD or BC, whatever we will get. So here A is H, B is Cl, react with C and D, that is called Na and OH. So what we will get? We will get H2O and NaCl. Decomposition or displacement reaction. Suppose if you are another reaction AgNO3, you are having solution of AgNO3 and a solution of NaCl. When we mix with each other, what we will get? We will get AgCl and NaNO3. So all types of reaction already you have studied in the previous years, but here as per the requirement of the syllabus, I have discussed some basic things with you. Definitions already I have given, but if you want to write something, then scientific method or proper sentence formation should be required. That's why I have written over here. A chemical species or of particular interest, the reaction on which with the other chemical reagent. This is most important. The reaction of which with some other chemical reagents is under observation or will take place, that is called substrate. Okay. The chemical entity whose conversion into product is also known as a substrate. So these are two definitions. Some more definitions may be available in various books. and online literature, but for your reference I have given two definitions for the substrate. Reactant, substrate will or substance initially present in the chemical reaction that are consumed during the reaction to make the product. What we have discussed? We have discussed about nitration reaction of benzene. So benzene react with HNO3, and this HNO3 is not present in the product, but it's another form or some part of the HNO3 will be in the product or present in the product, and that's why this compound is known as a reactant. Now catalyst, everybody is familiar with the term catalyst. Substance that speed up the chemical reaction or initiate the reaction, but is not consumed by the reaction. This is most important. Okay, it is not consumed by the reaction, and after completion of the reaction it should be or it must be available in its original form or recovered unchanged. It should be recovered unchanged. The type of compound or chemicals are known as catalyst. So in the previous reaction we have discussed about this sulfuric acid. Sulfuric acid was catalyst for nitration reaction. Okay, sulfuric acid only involved in the initiation of the reaction, means it involved in the generation of nitronium ion or nitrile ion, and then after completion of the reaction it is available in its original form, means again sulfuric acid we will get.
સર એકચ્યુઅલી અત્યારે વિકી સિંહ સરે લિંક ફોન કરી છે અને એ અમને એવું કહે છે કે તમે મારી એચડી પટેલ સર માંથી લીવ થઈ અને મારી લિંક જોઈન કરો, બાકી હું એવું સમજીશ કે તમારો સિલેબસ પૂરો એવું.
હા તો એમને કે એક જ મિનિટ, શું કીધું છે એમણે?
કે સિલેબસ પૂરો સમજીશું તમારો, એમ કે તમારો સિલેબસ.
આજે લેક્ચર કોનો છે?
તમારો જ છે, 10:30 to 11:30 તમારો જ છે.
હા તો મેસેજ મૂક્યો છે એમણે એવો કે કોલ કર્યું છે?
ના સર, કીધું છે કોઈને.
હા તો જેને કીધું હોય બરાબર, એ સ્ટુડન્ટ નું નામ શું છે? મારે આઈ થિંક હવે એ સ્ટુડન્ટ નું નામ શું છે? કયા સ્ટુડન્ટ ને કીધું છે? હું ઓનલાઈન આવી જાઉં છું, ફરી પાછું સ્ક્રીન શેરિંગ સ્ટોપ કરું છું. કયા સ્ટુડન્ટ ને કીધું છે? આમાં છે એ સ્ટુડન્ટ?
સર એમને જ્યારે પહેલો લેક્ચર સ્ટાર્ટ કરેલો ને ત્યારે એક વીક નું આખું એમનું શેડ્યુલ આપી દીધેલું.
હેલો સર.
હા અને સર પણ આજ તમારો લેક્ચર પણ છે અને એમને પણ અત્યારે લિંક મોકલી છે, એટલે બંને ભેગું.
સર એમને છે ને
સર એમને એક વીક પહેલા કહી દીધું હતું.
એક વીક પહેલા એમને કહી દીધેલું હતું સર અમને કે આવી રીતે તમારા લેક્ચર હું લઈશ એમ.
સર તમારો લેક્ચર પછી તમે કર્યો ને સર જનરેટ, એટલે સર પ્રોબ્લેમ આવ્યો સર.
એમને મારો તો શેડ્યુલ ટાઈમ ટેબલ મને આપેલો છે
સર. વી નો પડ સર, એને જનરેટ કરી દીધો તો અમે શું કરી શકીએ?
સર તમારો લેક્ચર તો શેડ્યુલ પ્રમાણે જ છે અત્યારે.
તમે સર એકદમ સાચા જ છો, એમાં કઈ ના નહીં સર.
હેલો સર. હેલો.
હા
હેલો. હા સર, અમે કોઈ સ્ટુડન્ટે આ શેડ્યુલ નથી મોકલ્યું, પણ વિકે જૈન સરે જ્યારે ફર્સ્ટ લેક્ચર લીધો ને ત્યારે અમને શેડ્યુલ મૂકી જ દીધું છે. અને જે તમારા શેડ્યુલ છે ને એમાં તમારો 10:30 નો લેક્ચર બતાવે છે, પણ આ વિકે જૈન સરે છે ને એમના શેડ્યુલમાં 11 વાગ્યાનો એમનો લેક્ચર મૂકી દીધો છે.
પણ આજે મંગળવાર છે ને, આજે મારો લેક્ચર.
સર એમાં એવું છે
સોમ મંગળ ને બુધ 3 દિવસ એમને મૂક્યો છે.
સર જે આજે રજા હતી ને સર 13-14 આજે જે રજા છે ને, એટલે સર એને એવું પ્લાન કર્યો છે કે રજામાં કોઈ લેક્ચર નહીં લે એમ, એટલે સર એને લેક્ચર લખે રાખી દીધો.
એવું થોડી હોય, કોઈને કન્સર્ન તો કરવું પડે ને.
સર તો અમને ખબર છે.
જો સર વિકે જૈન સર નો કેવો મેસેજ છે કે જસ્ટ ટુ રિમાઇન્ડ ધેટ વી વિલ બી હેવિંગ ક્લાસ સન્ડે 11 AM, મંડે 10 AM, ટ્યુઝડે 11 AM અને વેડનેસડે 11 AM. આ 4 દિવસને એમને લેક્ચર ગોઠવેલા છે. અને પેલું શેડ્યુલ તો ફોલો કરતા જ નથી. જે મેઇન શેડ્યુલ છે ને આપણે, એ આ એમને પોતાનું શેડ્યુલ આપ્યું છે.
યસ સર.
તો વાંધો નહીં, હું એમને જ હવે કોલ કરું છું.
યસ સર, કરો ને જરાક. પ્રોબ્લેમ સોલ્વ થઈ જાય.
ક્લેરિટી થઈ જાય. આ તો કેવી
Yes,
રીતે
sir, yes,
તમારે
sir.
લેક્ચર્સ લેવાના?
નહીં
તો
સર
સર
એકદમ
એમને
પરફેક્ટ
એવું
સર
કે
તમારે.
મારી લિંકમાં જોઈન થાવ ને અમારે આ લેક્ચર બી અટેન્ડ એક સાથે અમે બે લેક્ચર તો ના અટેન્ડ કરી શકીએ ને.
યસ સર રાઈટ હે સર.
એ ફોન ઉપાડતા નથી. ઓકે,
યસ સર.
એમને જ ફોન કર્યો છે. જો
Yes,
તમારા
sir, yes, sir.
સ્ક્રીન ઉપર દેખાય તો
Yes,
કઈ
sir,
નહીં, આપણે
દેખાય છે.
આપણો લેક્ચર કન્ટિન્યુ રાખીએ છીએ. 11:30 એ હું લીવ કરી દઈશ. અને એમને સિલેબસ ના ભણાવવો હોય તો આ
Yes, sir.
બહાનું હોઈ શકે એમનું, પણ આવી રીતે ના ચાલે. મને
સર
schedule
અત્યારે સર એમ કીધું કે તમે લેક્ચરમાં જોઈન થાવ, જો કોઈ એક લેક્ચરમાં જોઈન નહીં થાય ને તો એ કે હું પૂરો સિલેબસ સમજી લઈશ એમ કે
કઈ
સિલેબસ
નહીં,
પૂરો થઈ ગયો.
આપણે વીસી સર જોડે વાત કરી લઈશું. બરાબર, તમે
sir.
બિલકુલ ચિંતા ના કરો. શેડ્યુલ અમને આપ્યો છે, અમને કોઈ ઇન્સ્ટ્રક્શન નથી આપી કે એમના 11 વાગ્યાના બધા લેક્ચર્સ છે. બરાબર
ઓકે સર. સર યુ આર પરફેક્ટ પર ક્યાં કરે સર?
ના ના, જ્યાં સુધી મેં કાલે પ્રણવ સરને જોડે પણ વાત કરી છે અને એમની સાથે કન્સર્ન કર્યા પછી જ મેં લેક્ચર સ્ટાર્ટ કર્યા છે.
Yes,
પ્રણવ
sir.
સર કે આપણે આપણા શેડ્યુલ પ્રમાણે લેક્ચર લેવાના. હવે મારો એમનો લેક્ચર ગોઠવવો હોય ને એને ક્લેશ થાય તો એમાં મારો પ્રોબ્લેમ નથી. હું મારા શેડ્યુલ પ્રમાણે જઉં છું.
યસ સર તમારું schedule
સર
સર
આપણે છે ને આજે શેડ્યુલ છે ને આપણે મેન એ પ્રમાણે આપણે જઈએ
સર
એ પછી એમનો જે લેક્ચર હશે ટાઈમ ટેબલમાં એ પ્રમાણે આપણે લઈશું. આપણે આપણા લેક્ચર પ્રમાણે લઈ લઈએ.
ઓકે, થેન્ક યુ સો મચ. થેન્ક યુ સો મચ.
યસ સર.
So that's here catalyst means the chemical compound which we can use to carry out reaction, but this compound can initiate the reaction, this compound can speed up the reaction, but after completion of the reaction it will be available in its original form. That's why we can say that it is not consumed by the reaction and recovered. This is most important. It is recovered and in unchanged form. This is also important at the end of the reaction. There are different types of catalysts we can use. The catalyst may be sunlight. Suppose if you want to carry out photochemical reaction, let's say example of chlorination. In the chlorination we generally use sunlight. So sunlight can initiate the rate of the reaction or can initiate the reaction. Means what role of catalyst? The catalyst means sunlight can dissociate Cl2 in a free radical form, that is called Cl free radical and Cl free radical, and then after the reaction will take place. So here sunlight is only involved in the decomposition or breaking of the molecule to generate free radical. So this is called role of sunlight as a catalyst in the chlorination reaction. Second example I have given, that is chlorination by FeCl3. Or I think you are very much familiar with the Friedel-Crafts reaction. In the Friedel-Crafts reaction, you required alkyl halide plus AlCl3. Now AlCl3 react with what? Alkyl halide, and it will convert it into AlCl4 minus, and then after Ca3 plus is formed. When the Ca3 plus is formed, at that time, okay, AlCl3 only involved in the breaking of alkyl halide, and after completion of the reaction AlCl3 will again available in its original form. So it is known as catalyst for the reaction. Sometimes heat can also involve in the reaction, means high temperature can also initiate the reaction and we will get the intermediate. In some reaction, some biocatalysts are also involved in the reaction. Simple example, digestion of the food. Digestion of the food is also known as chemical reaction. Suppose if we have taken a food, in the food, suppose rice, potato and milk, etc. are there. So if you are having rice, milk, potato, etc. are there, it means in your body carbohydrate is there, sugar is there, protein is there. So in stomach you are having many chemicals, but the bacteria, those are present in our body having tendency to digest the food. But for the digestion of food, bacteria involve as a catalyst only. They can initiate the reaction, they can or they are having capacity to digest or decompose the food, and after completion of the reaction they can again or they are again available in its original form. So these are known as biocatalyzed reaction. So many types of catalysts are available. As per the requirement, we can use different types of catalyst for the reaction. Now the main term that is called reagent means, as per the syllabus we are going to discuss about the term reagent. In the beginning we have discussed about the various types of reagents. We have discussed the reagents for uh, identification of microorganism, reagents for identification of say, some inorganic compounds, reagents for identification of some organic compound. So likewise, reagents can the term reagents can be used for many purpose, but here we are going to use term reagent. That term is related with the chemical reaction, where reagents are the chemical compounds, those chemicals compounds which we can use to initiate the reaction, which can accelerate the rate of reaction, but again I am using word, but they are not available or recovered in its original form after completion of the reaction. So this is the minor difference between reagent and catalyst. Okay, reagent અને catalyst માં ફરક એટલો જ છે કે reagents જે છે એ reaction initiate કરે છે, rate of reaction increase કરે છે, પણ reaction પૂરું થયા પછી કેટલિસ્ટની જેમ ઓરિજિનલ ફોર્મમાં એ મળતો નથી અથવા રિકવર થતો નથી, એનું અનધર ફોર્મ અથવા બીજા ફોર્મમાં એનું કન્વર્ઝન થઈ જાય છે. So I think it is clear to all that is what is reagents in organic synthesis. એટલે કે ઓર્ગેનિક સિન્થેસિસમાં રિએજન્ટનો શું રોલ છે તે આ ડેફિનેશનથી ક્લિયર થઈ શકે. જો કોઈને ડાઉટ હોય તો અહીંયા પૂછી શકે, ના હોય તો as per the syllabus we will discuss about the 10 different types of reagents for organic synthesis.
Sir,
okay.
organic reaction જે રિએક્શન રેટ ઘટાડે જો કદાચ કોઈ સબસ્ટન્સ, તો એને શું કહીશું? એને કેવી રીતે ડિફાઇન કરીશું?
રિએક્શન રેટ
ઘટાડે એમ મતલબ એના પ્રેઝન્સમાં રિએક્શન એમ સ્લો થાય.
સ્લો ડાઉન રિએક્શન કરે. So catalyst having two kind of role, means they are known as controller of the reaction. Normally when we are talking about the catalysts are accelerating the rate of reaction, speed up the rate of the reaction, but the technically or scientific or proper word or proper definition of catalyst is having tendency to control the reaction. પણ આપણે normally આપણે use કરીએ છીએ કે speed up the reaction. No, it having tendency to control the reaction. So catalyst can reduce the rate of reaction also. But when we are talking about reduce the rate of the reaction of any compounds, then temperature also plays an important role, because the efficiency of catalyst is related with the temperature. If you change the temperature, if you increase the temperature, means you are increasing the activation energy. When you are increasing the activation energy, then the rate of reaction or the speed is high. But when we are reducing the temperature, the activation energy is decreased, and that's why we can carry out the reaction at a control way or in a lower stage. So catalyst can involve in both the ways, speed up and to reduce the rate of reaction. So the proper term is catalyst can be used to control the reaction. Okay. Is it clear?
Yes, sir.
So as per the syllabus, we will discuss about the different types of catalyst. Okay, total 10 reagents, total 10 reagents in our syllabus. So what we have to discuss? We have to discuss, or we will discuss about the 10 reagents, their mechanism, means how they are involved in a particular reaction. Okay, then after selectivity, why the specific type of reagent or reagent is used to carry out specific reaction only. Then utility of the following reagents, means where we can use, means how many types of reaction we can carry out. The first one is known as HATU, HATU. This is first time introduced in your syllabus. That's why I have put as a red. Then LDA, lithium diisopropyl amine. It's a base which we can use for the reaction. Then DCC, dicyclohexyl carbonamide. This is known as a dehydrating agent. DCC is known as dehydrating agent. So whenever in the reaction the water is eliminated, and due to the presence of water, if reaction is reversible, then in that condition we can use DCC. Then 1,3-dithione. This reagent having special characteristic. It means, suppose if you are talking about carbonyl group, C double bond O group. In the C double bond O, carbon is electropositive and oxygen is electronegative. But with the support of this 1,3-dithione, or with the support of 1,3-propane dithiol. This is the name of the reagent. This is the term which here it is mentioned. It is intermediate term, but actual name of the reagent is 1,3-propane dithiol. By using the 1,3-propane dithiol, we can change the polarity or characteristic of carbon. As I said, in carbonyl group, the carbon is electropositive, means electrophile. But by using this reagent, we can convert it into nucleophile. We will see how we can change the polarity or the characteristic of the particular atom. Then next one is DMP, Das Martin per iodine. DMP is known as oxidizing agent, and especially this is a organic oxidizing agent. Normally you have studied about the various types of oxidizing agents like KMNO4, then K2Cr2O7, Na2Cr2O7. You are having many oxidizing agents, but all oxidizing agents are organic, inorganic in nature, and they are having a specific element that is called transition elements are present in those oxidizing agent, and that's why they are creating environment pollution. So here we are going to use organic oxidizing agent. Its name is DMP. Then next one is Dibal H, diisobutyl aluminum hydride. This reagents we can use for the reduction reaction. Then next one is sodium cyanoborohydride, NaBH3CN. Now this sodium cyanoborohydride having specific type of characteristic, and due to the presence or by use of this reagent we can carry out reductive amination. So two reactions simultaneously we can carry out. One is reduction, second is amination. So it is known as reductive amination reaction. Next one is DDQ. DDQ again oxidizing agent. Then N-bully or N-butyl lithium. This is highly used reagent in industry and in R&D centers. So these reagents we can use for alkylation reaction. We can generate the carbon ion, and we can carry out the many more reactions with the support of N-bully. Its name is N-butyl lithium. And last one is phase transfer catalyst. Now phase transfer catalyst, again it's new for you. The reason is you are familiar with the two phase, that is called aqueous phase and organic phase. But sometimes what happen in many reaction, some compounds are soluble in organic phase, means they are in organic environment, and some compounds are soluble in water. So two phase we are having, aqueous and organic. Now if you want to carry out the reaction of a particular type of reagent, in that case what happened, only on the surface of two liquid, that is called aqueous and organic, only the reaction will take place. But with the support of phase transfer catalyst, we can carry out the reaction homogeneously, means your reagent or reactant in organic phase and substrate in inorganic phase, suppose, or sometimes it is revert, your reagent or reactant in a aqueous phase and your substrate in an organic phase. Now if you want to carry out reaction, then reactant should transfer from aqueous phase to organic phase, and that can be possible with the support of phase transfer catalyst. So we will discuss about the phase transfer catalyst, and mainly quaternary ammonium salt we can use as a phase transfer catalyst, and we can carry out many reactions with the support of phase transfer catalyst. So many things we will discuss in semester 2, and whatever the topic we will discuss, or whatever the reagents we will discuss, all reagents are having it's important in the industry as well as in the NET exam or in the SLAT exam. So here we have taken selected reagents, but if you go by Google search, then you will find many reagents for organic synthesis. You can find several books on the reagents only, because without the reagents it is sometimes, or it is not possible to carry out the reaction. Of course, the catalyst having its own important, the catalyst having its own characteristic, but reagents are also nowadays people are using or industries are using, and with the support of reagents we can prepare various compounds. Here the simple example, suppose if you want to carry out esterification reaction, here I have taken one example. Suppose if you want to carry out a esterification reaction, okay, what we require, carboxylic acid and alcohol. This reaction is very much familiar reaction, as you know, by using these two chemicals, means acid and alcohol, we will get R C double bond O OR1, that is called ester we will get. This is common reaction. Normally we use sulfuric acid as a catalyst for the reaction, but during the reaction water as a byproduct. So when water as a byproduct in the reaction, then what happens? For the hydrolysis of ester, what we require? Ester, water and sulfuric acid. So from this reaction what we will get, again RCOH plus R1 or OH. So when we start the reaction, in the initial you will get new product, that is called ester. But after completion of 50% of the reaction, when water is in a sufficient amount, then reversible reaction will start and you will get again acid plus alcohol. So at any point of time you will not carry out the reaction excess of 50%. એટલે કે 50% થી વધારે reaction થતું જ નથી, કારણ due to the presence of water the reversible reaction is take place and we will get again alcohol plus acid. So to avoid such problem we have to use the reagent, its name is DCC, dicyclocarbonamide. Okay, we will discuss in detail how these reagents will involve in the reaction, what is the mechanism of it and how we can recover it, how it act as known as a reagent, not as a catalyst. Everything I will discuss in detail, but for your reference only, what we are going to discuss in this chapter in the semester 2, that I have given or highlight I have given over here. From next lectures, we will start one by one and we will discuss in detail. So one reagent, its name is DCC. DCC is useful in how many reaction you can see. Synthesis of ester, synthesis of peptide, peroxide, amides, then heterocyclization, hydroxylation of alcohol, alpha beta unsaturated ketone, ether, thioether, diazoketone. Means one reagent is useful for many reaction. Okay, so these kind of reagents we will discuss in detail in semester 2, and also I will give you some examples related to the particular type of reaction. Some maybe I will give you in a homework because it is very much difficult to explain each and every application for the each and every reagents, but the general or basic concept I will explain. I will also cover 1-2 examples with a suitable compound, and then after I will give you some homework, because if you practice it, then definitely you will learn more during the semester 2. So I hope with this note, or I have explained the point or basic thing over here. So if you have any question or query, you can ask me. Otherwise, we will discuss the things in detail from next time.
Hello, sir. So what is the difference and similarity between the reactant and
Reactant and
reagent.
reactant and reagent. Okay. So in the last session, I have last slide I have given the example of esterification. In the esterification, I have taken carboxylic acid, okay, then alcohol and DCC. So here carboxylic acid known as a substrate. Alcohol is known as reactant, okay, and DCC is known as reagent. So DCC can initiate the reaction. Then after, alcohol will bind or attack on the acid. So here alcohol is known as reactant and DCC is known as reagent. Okay, Jill?
Okay, sir. Thank you.
कोई बीजा ने कोई क्वेश्चन क्वेरी? ઓકે, તમારા યુનિવર્સિટી એક્ઝામ એટલે કે સેમેસ્ટર 1 ના માર્ક્સ બધા આવી ગયા છે અને ટૂંક સમયમાં તમારું રિઝલ્ટ ડિક્લેર થઈ જશે. સો ઓલ ધ બેસ્ટ ટુ એવરીવન, કેમ કે તમે ઓનલાઈન એક્ઝામ આઈ થિંક ફર્સ્ટ ટાઈમ આપી છે. અમુક લોકોએ સેમેસ્ટર 6 માં આઈ થિંક ઓપ્શન લીધો હતો, પણ એમએસસી ની ફર્સ્ટ ટાઈમ આપી છે. તો જોઈએ હવે ટૂંક સમયમાં અમે એની પ્રોસેસ કમ્પ્લીટ કરી દઈશું. ઓકે, થેન્ક યુ એવરીવન. તમે બધા પ્રેઝન્ટ રહ્યા?
હેલો સર.
હા હા બોલો.
થેન્ક યુ સર.
હા સર, તમારે જેની અંડર સેમિનાર અને અસાઇનમેન્ટનું ગ્રુપ થયું છે તો એમના માટે કંઈક ડિસ્કશન કરવું હોય તો.
હા, એ આપણે આજે શું કહે ફર્સ્ટ ડે છે. સેમિનાર એસાઇનમેન્ટનું ઓલરેડી મેં ગ્રુપ બનાવી દીધું છે. ગ્રુપમાં કોઈ ખાલી 1 કે 2 જણા પ્લસ માઇનસ થયા છે, તો એ હું ફરી એડ કરી દઈશ અને એનું આપણે સેશન અલગથી લઈ લેશું, સેમિનાર એસાઇનમેન્ટ. ઓકે
ઓકે સર.
થેન્ક યુ એવરીવન. આઈ
Thank you,
એમ
sir.
લીવિંગ ધ મીટિંગ.
થેન્ક યુ સર.
સર રેકોર્ડિંગ સેવ કરી દેજો સર.
હા, એ ના, હવે રેકોર્ડિંગ ઓટોમેટિક સેવ થઈ જશે. તમારે તમારો સેશન જ્યારે એન્ડ થાય, હું એન્ડ કરું પછી
Yes,
એ
sir.
તમે જોઈ શકો. તમે જાતે પણ ડાઉનલોડ કરી શકો. બરાબર?
Okay,
એમએસ
sir.
ટીમના પેલામાં જઈને એ સાઇટ ઉપર જઈને તમે કરી શકો.
ઓકે સર.
ઓકે, થેન્ક યુ.
થેન્ક
થેન્ક
યુ
યુ
સર.
સર.
Hello,
થેન્ક યુ સર.
હા બોલો.
sir.
હા,
Sir, I'm not in your MS team group. તો મને એમાં એડ કરી દેજો ને.
તો તમે અહીંયા છો તો એડ જ હશો ને, કેવી રીતે ના હોય?
ના સર, હું છે ને અમારા લોકોનો અનઓફિશિયલ ગ્રુપ છે ને એમાં જે લિંક આવે છે ને એમાંથી જોઈન થાઉં છું.
તમારું મેલ આઈડી આજે મને મોકલી દો.
ઓકે સર, થેન્ક યુ.
તમારું મેલ આઈડી મોકલી દો, રોલ નંબર મોકલી દો, હું એડ કરી દઈશ. એવું કોઈ બીજું હોય તો મને આજે જણાવી દેજો, કેમ કે HPP માં પણ 2 સ્ટુડન્ટ એવા નીકળ્યા કે જે લોકોનું આ ટીમમાં નહોતા. તમે એડ કરી દીધા છે. તમારામાંથી કોઈ બીજા હોય અથવા કોઈ બીજા ફ્રેન્ડ્સ હોય તો મને જણાવી દેજો. ઓકે
ઓકે સર, થેન્ક યુ.
થેન્ક યુ.